Next topic, congruent triangles. What are congruent triangles? This is a triangle ABC. This is one more triangle DEF. If two triangles having same shape and same size, then they are called congruent triangles. So here these two are congruent triangles. Triangle ABC is congruent to triangle DEF. Not only triangles, if two diagrams having same shape and same size, they are called congruent diagrams. If they are triangles, they are called congruent triangles. If triangles are congruent, here these two having same shape and same size, therefore point number 1, corresponding sides are equal. Corresponding sides are equal, that is AB is equal to DE, AB is equal to DE, BC is equal to EF, AC is equal to DF. So if this is 7 centimeters, this is also 7 centimeters. If this is 6 centimeters, this is also 6 centimeters. If this is 8 centimeters, this is also 8 centimeters. The corresponding sides are equal. Point number 2. Corresponding angles are equal. Here angle between 8 centimeters and 7 centimeters is angle A. Here this is nothing but angle D. Therefore angle A is equal to angle D. Similarly angle B is equal to angle E. Angle C is equal to angle F. So corresponding sides are equal, corresponding angles also equal. Therefore, automatically, point number 3, if two triangles are congruent, then areas also equal. Area of triangle ABC is equal to area of triangle DEF. Corresponding sides are equal, corresponding angles are equal, and areas of those two triangles also equal. Then how to check whether the triangles are congruent or not? To check the congruency of triangles, we have to know 4 important properties. The first one is SSS property. Side, side, side. Side, comma, side, comma, side. What is SSS property? These 3 sides of one triangle equal to the 3 sides of the other triangle. We say that these two triangles are congruent. For example, this is 10, this is 12, this is 15. There is one more triangle 10, 12, 15. If this is A, B, C, this is D, E, F, then we say that these two triangles are congruent. The 3 sides of one triangle equal to the 3 sides of the other triangle, we say that they are congruent. So we have to write a triangle ABC is congruent to triangle. See carefully, writing congruency is very carefully. Here A lies between 10 centimeters and 12 centimeters. Here 10 centimeters, 12 centimeters, the vertex is F. So A related to F, A, and this is F. The corresponding vertex is F. Similarly, 10, 15 between B is there. Here 10, 15, D is there. So you have to write D. The third one is E. So you have to write triangle ABC is congruent to triangle FDE. Okay? Writing congruency very carefully, please. Okay? So this is called the first property, SSS property. The second one is nothing but SAS property. Side, angle, side. This is a triangle ABC. This is 5 centimeters, this is 6 centimeters. Let the angle between these two is some 70 degrees. There is one more triangle here, like this. If this is 5 centimeters, this is 6 centimeters. Let this angle is some 70 degrees. And we say that these two triangles are congruent. Side, angle, side. If two sides and included angle of one triangle equal to two sides and included angle of the other triangle, we say that the two triangles are congruent. That is SAS property. The third one is ASA property, angle, side, angle. This is a triangle. If this is some 70 degrees, let this be 30 degrees. The side between these two is some 10 centimeters. Here also, if this is some 70 degrees, let this be 30 degrees and this is some 10 centimeters. We say that these two triangles are congruent. Two angles and included side of one triangle. Two angles and included side. The side between two given angles is called included side. The two angles and included side of one triangle equal to two angles and included side of the other triangle. Then we say that the two triangles are congruent. The fourth property is nothing but RHS property. What is RHS property? In two right angle triangles, this is one right angle triangle, this is the other right angle triangle. For example, this is 5 centimeters, this is 4 centimeters, this is 5 centimeters, this is 4 centimeters. These two are right angles. We say that these two are congruent. In two right angle triangles, hypotenuse and one side. Hypotenuse and one side of one triangle equal to hypotenuse and one side of the other triangle. We say that the two right angle triangles always congruent. So these are four important properties of congruency. I want to discuss one problem based on this. This is a parallelogram ABCD where E is the midpoint of DC, join BE and extended, and AD also extended, which meets at F. If this is some 15 square units, the triangle area is 15 square units, what is the area of this triangle? This is also 15. But the question is, according to which property these two triangles are congruent? According to which property these two triangles are congruent? The answer is ASA property. Why? See here, this is a parallelogram. Okay? These two lines are parallel lines. Consider this as a transversal. This is also transversal. These two lines are parallel. This is also transversal. If this is transversal, this angle is same as this angle. Angle BCE is same as FDE. And this angle is same as this angle. These two angles are same. And already this is the midpoint, therefore this length is same as this length. So therefore, this angle side angle of this triangle same as angle side angle of this triangle. According to ASA are equal, therefore these two triangles are congruent. If triangles are congruent, then area is also equal. So area of this part is equal to area of this part. The next topic is similar triangles. What are similar triangles? Most important topic in geometry. This is a triangle ABC. This is one more triangle DEF. These two triangles having same shape, we say that these two are similar triangles. Triangle ABC is similar to triangle DEF. If two triangles having same shape but different sizes are different here, but having same shape, we say that they are similar triangles. Not only triangles, if any two diagrams having same shape, then they are called similar diagrams. Circles always similar diagrams, squares always similar diagrams. Not only in this, in 3 dimension also, spheres always similar, cubes always similar. If these two triangles are similar, so what are the basic properties of similar triangles? If triangles are similar, then number one, corresponding sides are proportional. If this is 5 centimeters, this is 6 centimeters, this is 7 centimeters, let this is 10 centimeters, 12 centimeters, 14 centimeters. The corresponding sides are proportional. AB by DE is the same as BC by EF is the same as AC by DF. If you magnify this, we get this one. The ratio of sides are same. Corresponding sides are proportional. Very important point. If two diagrams are similar, then corresponding sides are proportional. One question given in previous examination also based on this. I'll discuss all these the previous questions in one more session. What about point 2? Corresponding angles are equal. Sides are proportional but angles are equal. That is, angle A is same as angle D. Angle B is same as angle E. Angle C is same as angle F. Corresponding sides are proportional and corresponding angles are equal. Next, what about the ratio of sides? See here, the ratio of sides is equal to corresponding sides. Ratio of corresponding sides is 1:2. The meaning of that is not only the sides of the triangle, any two corresponding lines are equal. For example, if this is the midpoint, I want to draw a median. Here also draw median. If AX is the median and this is AY, dy. And these two medians are also in the same ratio 1:2. If sides of a triangle are in the ratio 1:2, medians also in the same ratio. Previous question given based on this. So the ratio of sides is equal to ratio of medians. Not only medians, if you draw altitude, height. If this is h, then what is correspondingly height? Nothing but 2h, because the ratio of sides 1:2. So ratio of altitudes see the perimeter 5 plus 6 11 plus 7 is equal to 18. Here this is nothing but 36. What about the perimeters ratio? Perimeters ratio is also 1:2. So ratio of perimeters. So ratio of sides is equal to ratio of medians is equal to ratio of altitudes is equal to ratio of perimeters. Not only this, if you consider this midpoint and this midpoint, draw a line. Here also this midpoint and this midpoint, draw a line segment, and these two are also in the same ratio. Any two corresponding lines or line segments are in the same ratio. That about the importance of similar triangles. Next, what about areas? See, ABC triangle, DAF triangle are similar. Let the sides are in the ratio 1:2. Let the base of this is B. Let the base of this is 2B. Because corresponding sides are in the ratio 1:2. And if you draw an altitude, let this be h. What is corresponding altitude? 2h. Then what about the area of first triangle? Area of triangle ABC is to area of triangle DEF is equal to half into base into height is to half into 2b into 2h. Half of cancel, BH cancel. This is nothing but 1:4. So if two triangles are similar, then ratio of areas is equal to square of ratio of sides. Ratio of areas is equal to square of ratio of sides. If ratio of sides 1:2, areas ratio 1:4. If ratio of sides 1:3, if this is 5, this is 15 centimeters, let it be. Then area of ratio of areas is equal to 1:9. Not only square of ratio of sides, square of ratio of medians, square of ratio of altitudes, square of ratio of perimeters. If two triangles are similar, then ratio of areas is equal to square of ratio of sides, square of ratio of medians, square of ratio of altitudes, square of ratio of perimeters. If perimeters ratio given, just square it, we get areas ratio. In the case of similar triangles, not only similar triangles, this formula is applicable for any similar diagrams. For example, there is a square here, this is a square. The side is x units, and this is one more square whose side is 2x units. Then what about the areas ratio? Nothing but 1:4. Sides ratio 1:2, areas ratio 1:4. Same in the case of circles also. If radius is doubled, what about the ratio of areas? Nothing but 1:4. Applicable for all similar diagrams. Next, how to check whether the triangles are similar or not? There are 4 important basic properties of similarity of the triangles. One is A property, or this can also be written as AA property. Angle, angle, angle. Here, this is a triangle. This is one more triangle. If this is some 70 degrees, this is 80 degrees, this is 30 degrees. Similarly, if this is 70 degrees, let this be 80 degrees and this is 30 degrees. We can say that these two triangles are similar triangles. If this is ABC, DEF, triangle ABC is similar to triangle at A 70 degrees, here F 70 degrees, at B 80 degrees, here E 80 degrees, 30 degrees, 30 degrees D. Triangle ABC is similar to triangle FED. If 3 angles of one triangle equal to 3 angles of the other triangle, we say that the two triangles are similar triangles. Actually, this is AA properties, and if 52 angles are same correspondingly, then automatically the third angle equal. So therefore, AA, if 2 angles of one triangle equal to 2 angles of the other triangle, we say that the two triangles are similar triangles. Point number 2. SSS property. What is SSS property? The 3 sides of one triangle proportional to the 3 sides of the other triangle, we say that the two triangles are similar triangles. If this is 4 centimeters, this is 6 centimeters, this is 7 centimeters. Let it be 8 centimeters, 12 centimeters, 14 centimeters. We say that these two triangles are similar triangles. The 3 sides of one triangle proportional to the 3 sides of the other triangle, we say that the triangles are similar triangles. These properties are very important, please. Based on these properties, we have to know the triangles are similar or not. If you know that the triangles are similar, the problem becomes very easy. Maximum questions in the previous questions based on similar triangles also. The third one is nothing but SAS property. This is a triangle ABC. This is one more triangle DEF. Here this side is some 6 centimeters and this is some 8 centimeters. Let this angle is 60 degrees. This is 12 centimeters, this is 16 centimeters. Let this angle is again 60 degrees. We say that these two triangles are similar triangles. Here important, the sides are in the same ratio. The 2 sides of one triangle proportional to the 2 sides of the other triangle, and included angles are same. Angles must be same between those 2 sides. If included angles are same, then we say that these two triangles are similar triangles. if two sides and included angle of, if two sides of one triangle proportional to two sides of the other triangle and included angles are same, then we say that the triangles are similar. This is called SAS property. The fourth one is RHS property. In two right angle triangles, this is a right angle triangle, this is one more right angle triangle. In these two right angle triangles, the hypotenuse and one side of one triangle proportional to hypotenuse and one side of the other triangle. Hypotenuse ratio and one of the sides ratio same. We say that these two right angle triangles are similar triangles. So these are four basic important properties of similar triangles. Very important, please. Okay, read carefully all these points. Next, this is a triangle ABC and D is a point on AC. If this is 10 centimeters, this is some 12 centimeters, this is 8 centimeters. What is BC length? If this angle is theta, if this angle is also theta. Solve the question. This question is based on similar triangles. If you know the two triangles in this, actually we have three triangles. This is one triangle, this is the second triangle, this big triangle is third triangle. In these three triangles, two triangles are similar. If you know that, then the problem becomes very easy. See here, triangle ABD is similar to triangle, this big triangle. Here in this small triangle, angle A is the same as angle A in the big triangle also. So this is common angle for small triangle as well as big triangle. Next, in the small triangle, angle B is a theta. In the big triangle, angle C is theta. So in the place of B, you have to write C. So these two angles and these two angles are equal. Therefore, automatically the third angle equal. What is the third angle in ABC? Nothing but B. So these two triangles are similar triangles. So after knowing this, the problem becomes very easy. So what we have to find? BC. We have to find BC. So if triangles are similar, the corresponding sides are proportional. BD by BC is equal to AD by AB, AD by AB. Just use BD. What is BD? 12 by BC, not known, question mark. AD 8 centimeters by AB 10 centimeters. Therefore, question mark is equal to 120 by 8, which is equal to 15 centimeters. This is 15 centimeters. This is a question based on similar triangles. Next, ABCD is a parallelogram. AC is the diagonal. Let Q is the midpoint of CD. BQ is joined and extended. AD is also extended, which means this BQ at R. Then what is BP is to PR is equal to how much? Here this question based on two concepts, that is similar triangles concept as well as the congruency of triangles concept. See here, this angle is same as this angle. Vertically opposite angles are equal if two lines intersect each other. And this is the midpoint, so this side is equal to this side, and these two are parallel lines. Consider this as a transversal, then this angle is same as this angle. So therefore, the two triangles, a triangle QCB is congruent to triangle QDR. If two triangles are congruent, then the corresponding sides are equal. So this side is equal to this side. QC is equal to QD. QC is equal to QD. Similarly, QR is equal to QB. QB is equal to QR. Okay? So this distance is same as this distance. Next, consider this PQC triangle and PBA triangle. These two are parallel lines. Consider this as a transversal. So this angle is same as this angle. This angle is same as this angle. Similarly, these two are parallel lines. Consider this as a transversal. So this angle is same as this angle. And these two are vertically opposite angles. Therefore, triangle PQC is similar to triangle PBA. The three angles of one triangle equal to three angles of the other triangle. We say that the two triangles are similar. So if triangles are similar, corresponding sides are proportional. For example, here, see carefully, this is x. So this is also x because these two sides are equal. And in parallelogram, opposite sides are equal, therefore this is 2x. And these two are similar triangles, these corresponding sides are in the ratio 1:2. QC by BA is equal to x by 2x is equal to 1/2. So not only this, the sides are in the ratio 2:2, 1:2, the other sides are also in the same ratio. So here PQ is to PB is also 1:2. If this distance is y, this distance is 2y. And according to the previous condition, QB is equal to QR. What is QB? Totally y plus 2y, 3y. So this is also 3y. Therefore, what is BP is to PR. BP 2y is to PR. Y plus 3y, 4y. So this is answer is 1:2. Here we have two concepts. One concept is related to congruency of triangles. The other concept is related to similar triangles. So if you know the properties, we have to solve this type of questions. These two triangles based on side angle side property, angle side angle property, ASA property, and this is nothing but AAA property. Next, already I have discussed in the previous class this one. This is a right angle triangle ABC, right angle at A. BC is hypotenuse. Draw a perpendicular to the hypotenuse which meets at D. This is altitude drawn to BC. I have given 5 important properties. Based on these 5 important properties, if this is P, if this is X, this is Y. then p square is equal to x into y, p is equal to bc by a, x is equal to c square by a, y is equal to b square by a, this total is a. All these properties also can be proved using similar triangles condition. Here we have three triangles. This is one triangle, this is the second triangle, this is the third triangle, big triangle. All these three triangles are similar triangles. See carefully. I want to consider this angle as theta, and this is nothing but 90 minus theta, because this is 90 degrees. And this is altitude, therefore this is 90. Already this is 90 minus theta, 90, what is this angle? Theta. This is theta, this is 90, therefore what is this angle? This is nothing but 90 minus theta. Triangle ABC, A is 90 degrees, B is 90 minus theta, C is theta. 90 degrees, 90 minus theta, theta is equal to triangle. I want to compare this with this BAD. In this triangle 90 degrees at D, in this triangle 90 minus theta at B, in this triangle theta at A. So triangle ABC is similar to triangle DBA. Okay, similar. Sorry. Similar. This is similar to 90 degrees at D, 90 minus theta at A, theta at C. So triangle ABC is similar to triangle DBA is similar to triangle DAC. All these triangles are similar triangles. Just apply corresponding sides conditions, we can get all the 5 properties. For example, I want to consider these two. AB by DB is equal to BC by BA is equal to AC by DA. See, what is AB? AB is nothing but C, DB is nothing but X, BC is A, BA is C, AC is B, DA is P. If you equate these two, X is equal to C square by A. Already I have given this property. And equate these two, P is equal to cross multiply, we get BC by A. This is also given. Like that we can prove all the 5 properties using this condition. Here, very important, in a right angle triangle, if altitude drawn to hypotenuse, then all the 3 triangles are similar triangles. Next, this is a triangle ABC. Here, this line and this line are altitudes, they meet at O, orthocenter. This is median, this is also median, they meet at centroid. Point of intersection of medians is centroid. Draw perpendicular to BC at the midpoint. Here also this is midpoint, draw perpendicular, they meet at circumcenter. Point of intersection of perpendicular bisectors is circumcenter. Already I have discussed OGS are collinear, and this line is called Euler's line. They are always OGS collinear, and already I have given G divides OS in the ratio 2:1 internally. GO is to GS is equal to 2:1 internally. G divides OS in the ratio 2:1 internally. Actually, how to prove this? And this is one more important concept, see carefully, based on similar triangles. Here this line and this line are perpendicular to BC. So these two are parallel lines. If these two are parallel lines, this is a transversal, then alternate interior angles are equal. So these two are parallel lines. Consider this Euler's line as a transversal. Therefore, this angle is same as this angle. Consider this triangle. This is the one triangle. This is the second triangle. In this, angle O is equal to angle S. Next, at G, vertically opposite angles are equal. This angle is same as this angle. So if two angles are same in two triangles, automatically the third angle is same as the third angle here. Therefore, triangle GOA is similar to triangle GS, let it be some P. These two triangles are similar. AG is to GP. If this is the median, median is divided by centroid in the ratio 2:1 internally. Here GA is to GP is equal to 2:1. If these two are in the same ratio 2:1, the remaining corresponding side is also in the same ratio. So if GA is to GP is 2:1, GA is to GP is 2:1, GO is to GS is also in the ratio 2:1. GO is to GS is also 2:1. Very simple proof. So therefore, OGS always collinear and G divides OS in the ratio 2:1 internally. And this triangle and this triangle always similar. For example, distance between orthocenter and vertex is some 10 centimeters given. What is this distance SP? What is the distance from circumcenter to this base BC? If this is 10 centimeters, this is 5 centimeters. In triangle ABC, if O is the orthocenter, S is circumcenter, distance from orthocenter to A is given, then what is the distance from circumcenter to the line segment BC? Is nothing but half, because they are also in the ratio 2:1, 2:1, 2:1, 2:1. This is an important concept, please, based on similar triangles.